All right, crew, this is a biggie, but our calculator is going to make this easier for us. So follow along and we'll do this again in class tomorrow. So we are looking at solving a triangle when what we know is two sides at an angle. And I want to talk just a minute about why this is called the ambiguous case, right? Ambiguous means that you can't know for sure. There's some question into what the conclusion is. So we didn't get to the spaghetti project, but I want to just kind of give you a quick sketch on what would happen here. So if I had a piece of spaghetti and I cut off one to be 10 centimeters and one to be 5 centimeters, and I set the 10 centimeter piece at a 30 angle to the base of the triangle, then the idea is I've got this long piece of spaghetti, and I'm not really cutting that off, and then I take my 10 centimeter piece and I put it at a 30-degree angle. So I set my 10 centimeter piece, so it's at, oh, that's probably more than 30. Let me start over here. So I've got my base of my triangle, and then I've got my 30-degree angle with a 10 centimeter piece. So this is 30 degrees, and let's say this is 10 centimeters. And then I'm going to take a second piece, a 5 centimeter piece, and I'm going to hook that on to this 10 centimeter piece. But I don't know at what angle, so I just need to extend that 10 centimeter piece. So if I take a piece that is half as long as my 10 centimeter piece, I could set that maybe here. Let's say that's 5 centimeters. And I have a triangle. So I have a triangle with a 30-degree angle, and then it's got some angle here. So if I call this triangle ABC, B has a set angle, and then C has a set angle, right? But that's not the only place I can put that 5 centimeter piece. If I take this 5 centimeter piece and I swing it this way, then I've got this triangle where this is side C, and in this case angle B is smaller than it was for my blue triangle, angle C is bigger than it was for my blue triangle, but this side is still 5 centimeters. So this just illustrates that with two known sides, right, I know this side, I know this side, and then I know an angle. So in the side-side angle case, it is possible to build two different triangles that have those specifications, right? So since we don't know which one we're trying to find, that's why we call it the ambiguous case. So if we come along in there, the way we're going to solve the triangles that have this side-side angle case is we're going to use the law of cosines in order to solve that, which is consistent when we know at least two sides. We use law of cosines. But we're going to follow these steps. So we're going to start with the side opposite the known angle. We're going to plug that into law of cosines, which is going to give us a quadratic equation. We're actually going to use the quadratic formula, right, which is here, in order to solve for our unknown. And that's going to give us two positive values that come from the plus and minus. And two triangles are possible. Now it's possible we could come up with only one triangle, and that would happen when this quantity here is 0, or it's possible that we can actually come up with no triangle when this quantity here is negative, and we can't do that. So if our quadratic formula yields both a positive and negative value, that's another case where we can get only one triangle because it wouldn't be possible to have a negative angle. Right? So we're going to walk through these steps. You've got these written here. I'm going to show you an example. So in this example, I have triangle XYZ, and I'm given the length of two sides. So this is a side, this is a side, and then I have an angle, which is 26 degrees. So if I draw that triangle, I might come in here, and I'm going to put X here, and I'm going to bring out a side, and then I've got side Z is 80, so I'm going to come out well, angle X is 26 degrees. So I'm going to come out at about 26 degrees. And I'm going to bring out my side Z, which is 80 centimeters. And then side X is 50. So if this is 80, half of that is 40. 50 is a little longer. So maybe I come out here, and this is side X across from angle X, and it is 50 centimeters. So if this is side Z, this is angle Z, this would be side Y, and this is angle Y. Now again, like we just looked at, that's not the only possible triangle. I could also have a triangle where I swing this 50 centimeter piece this way, in which case I have angle Y here, and this would be my angle Z, and this would be my side Y. So my side Y could extend all the way from here to here for my bigger blue triangle, or it could go from here to here for my smaller green triangle. Okay, so I have that ambiguous case. So this is what we're going to do. Okay. So the first thing we're going to do is we've got side-side angle, which tells us we're going to use law of cosines. Now, law of cosines says that any side squared is the sum of the squares of the other two sides minus 2 times the product of those other two sides times the cosine of the angle that is opposite, right? Remember, this angle is opposite this side. They're opposite each other. Now, here is my problem. The only angle I know is angle X, 26. And I know the length of the side opposite that angle. It's 50 centimeters. What I'm trying to find is side Y, but it is not opposite my angle. So I only know this angle, it's 26. It has to go where A is. And what goes here has to be what's opposite, which is 50. So when I fill that in, I'm going to write this. I have, for my side opposite my angle, 50 squared equals my other side, which I know is 80 squared, plus the other side, which I don't know, so that's y squared, minus 2 times the product of those sides, so times 80 times y, times the cosine of the angle opposite this side, right, which is 26 degrees. So before we go farther, trying to get this out of the way. Doesn't want to get out of the way. Let's move it down. Let's see if we're there. Oh yeah, I got plenty of space. Let's simplify what we've got here. So I've got 50 squared, which is 2,500 equals 80 squared, which is 6,400, plus y squared minus 2 times 80, which is 160. And I'm going to swap the order of these two terms. So I have the cosine of 26 degrees times y. Now when I look at this has my variable in it, which is y, and that variable is showing up in two spots. It's showing up here, and it's showing up here. In one case, that variable is squared, so this is a quadratic equation. And when we solve quadratic equations, we want to get them equal to 0. So I'm going to come in here, and I'm going to subtract this 2,500 from both sides of the equation, which gives me 0 equals. Now, these are both just numbers, so I can subtract them, and that gives me 3,900 plus my y squared minus my 160 times my cosine of 26 degrees times my y. I like quadratic equations to be in the form of ax squared plus bx plus c equals 0. Now in this case, my variable is y instead of x. And I'm going to rearrange this equation so it looks like this. So I'm going to come in here and I'm going to write my y squared term first. So I've got y squared. Then I want to do plus my b. Well, my b is this negative 160 times the cosine of 26. So I've got plus negative 160 times the cosine of 26 degrees. And that is multiplied by my y. And then I have my constant, 3,900, and that equals 0. So totally fine for me to put a 1 here. And when I do that, I can see that my a is 1, my b is negative 160 times the cosine of 26, and my c is my constant, 3,900. So I want to take that and I want to put that into the quadratic formula. So let's just kind of review that quadratic formula. Your quadratic formula says, right, quadratic formula says that your variable, right, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So, right, again, my variable is y, so I'm really solving for y here. And I could plug all this in, but that's going to get pretty big and gnarly. So that's a term from the 70s, just kind of means ugly, nasty, difficult. So I'm going to use this fancy calculator we have to do something really cool. And this is, I'm going to write it first and then we'll do it. So we're going to come in here and I'm going to take, on my calculator, this is what I'm going to type. Okay, I want to store each of these values to A, B, and C. So I'm going to type 1, and then I'm going to hit the button on my calculator that says stow. We've done this before. And then I'm going to access the letter A, and then I'm going to press enter. After that, I'm going to enter what B equals. So I'm going to enter negative 160 times the cosine of 26 degrees. And I'm going to store that, so I'm going to hit stow, my stow button, this is an arrow, in B and press enter. And then I'm going to take 3,900 and I'm going to store that in C and press enter. Before we go on, let's go ahead and look at that. So I'm going to come back down here to where I put this document, Cameron. Let's pull this up and let's do this on the calculator. Okay, so I'm going to turn my calculator on. Okay, I'm on this screen because I want to make sure that I've got degrees, and I do. And so then I'm going to go back and I'm going to type exactly what we said. So I'm going to take 1. See what I'm doing here? Then I'm going to hit this button here which says store. I want to store that to A. A is up here, it's green, so I've got alpha, math gives me A. Press enter, and it tells me it's putting in 1. Then I'm going to take my B value, which was a negative number, so I've got negative 160. I'm going to multiply that by the cosine of 26. And we're going to take that and we're going to store that, so I've got my stow button again. And we're going to stow that in B. So B is on this apps button, so I've got alpha, apps, that's B. Press enter, and it's giving me the decimal equivalent of negative 160 times the cosine of 26. Now I'm going to take 3,900, and I'm going to store that for C. So now, anytime I type A, B, or C, the calculator is going to use those values. All right, we'll come back to this in just a second. So here we go. So now we're going to type this. So now we're going to type this. We're going to type the quadratic formula. And so I've got a horizontal fraction bar, which I'm not going to use. So I'm going to do open parentheses for my numerator. Then I'm going to use negative. Make sure you're not using subtraction. B. I don't have a plus or minus button, so I'm going to start with just plus, and we'll come back and change that to minus. And then we're going to do the square root, which automatically gives me an open parentheses. And then I'm going to do b, and we're going to square that. You don't have to put b in parentheses because the calculator is going to use it exactly as it is. Then minus 4, and then we're going to multiply that by a, and we're going to multiply that by c. We're going to close parentheses to end the square root, and then we're going to close parentheses to end the numerator, and then we're going to divide by. For the denominator, we're going to put that in parentheses. So we've got open parentheses 2 times a. All right, let's go back to the calculator and look at how that plays out. Okay, so I've stored all these for a, b, and c. And I'm going to come in here and do exactly what I said. So I've got open parentheses, negative, not minus, negative b plus the square root of b plus the square root of b squared, so I'm going to square that, minus 4 times a times c. Okay, so if I had parentheses, I would close my parentheses to end my square root. I'm going to use my right arrow to jump out of that square root, and I'm going to close my parentheses to end my numerator. So opposite of b plus the square root of b squared minus 4ac all over, so we're going to divide by, open parentheses for the denominator, 2 times a. And I'm going to press enter. And I get 107.542. So when I come back up here, from this, I get that, so this is what y equals, so I get y equals 107.542, and in this case, that would be measured in centimeters. Now, for us to find our other possibility, remember with the ambiguous case, we have 2 possibilities. I'm just going to come in here, and I'm going to change this plus to minus. So I've got my opposite of b minus now the square root of b squared minus 4 times a times c all over 2 times a. All right, so back to the calculator. These lovely calculators, I can just go up, so I'm hitting my up arrow and press enter. So now I can make some changes, and I'm going to come back using my left arrow, and I'm going to change this plus before the square root to a subtraction, and then I'm going to press enter right where I am, and I get 36.265. So now I'm going to come back here, and for this one, I get my second option, so this is y1, we'll call this y2, and it is 36.265 centimeters. So, if I were to solve this triangle, for me to solve my triangle means, right, so to solve the triangle, means that I want to find side x, side y, side z, and I want to find the measure of angle x, angle y, and angle z. And I've got to do that for 2 different triangles, right? So I've got to do that for triangle 1 and for triangle 2. Well, for both of them, we know that the measure of angle x was 26 degrees, so that's going to be the same. Okay, for both of them, we knew that side x was 50 centimeters. We knew that side z was 80 centimeters. And then for our first triangle, we had that side y, so this was new information to fill in. Side y was 107.542 centimeters. And for triangle 2, it was only 36.265 centimeters. So that's my smaller triangle. So what I have left is finding my angles. At this point, I know 2 sides at an angle, trying to find a third. So to find my angles, I'm going to use, to find these angles, I'm going to use law of cosines. And I would get that angle y will equal the inverse cosine of 50 squared plus 80 squared minus my 107.542 squared, sorry, and then I'll divide that by 2 times 50 times 80, right, and all of that goes into my inverse cosine. So for the other one, I would just replace this 107 with my 36.265. So let's just kind of go back to the calculator and look at that. So I'm going to come up here and I'm going to do this. Okay? I'm going to come up here and take this 107. And I'm going to take that and I'm going to store that. So I'm going to take it and I'm going to store that for y. So that's down here. So alpha, store that for y. Okay. So now when I use my law of cosines, I can do my inverse cosine of 50 squared. Oh, sorry, let me come back. I started a numerator, so I need an open parentheses of 50 squared plus 80 squared of 80 squared minus what I just stored as y. So I'm going to pick up that y of y squared, close the parentheses, divided by open parentheses for my numerator, 2 times 50 times 80, close parentheses for inverse cosine, and I get 109.461, which would be my measure of angle y. So to adjust that, I can take, right, for my second triangle, I could just come in here and go back to this 36.264, and if I now store that as y, then when I come back here to get this inverse cosine, which I've already entered, I can evaluate that, and it's going to give me my other y value. So picking up those values, I now have the measure of my angle y is 107 point, no, I'm sorry, was 109.461 44.461 degrees for my bigger triangle, or 36.265 degrees. If we just then use the idea that the sum of the three angles have to equal 180, we can find the third angle, and this one would give me 44.539 and 135.461. So I think I'm going to stop there for today. I do have another example. We'll talk about that in class tomorrow, and we'll do this together tomorrow as well. I know there's a lot to it, but again, you can do it. You can prove it to me all the time.